It's cold, it's tiny, and it's no longer a planet. But what if Pluto has been hiding something all along? Imagine an alien world where life exists in the most unlikely place, beneath a crust of ancient ice in oceans darker than night. Scientists once dismissed Pluto as a frozen rock. Now, some think it might be one of the solar system's most mysterious and possibly livable worlds. Today, we dive into the chilling theory of life on Pluto. Pluto, once the ninth planet, was reclassified as a dwarf planet in 2006. It's about two-thirds the size of our moon, lies nearly 4 billion miles from the sun, and its surface is negative 375 degrees Fahrenheit, cold enough to freeze nitrogen solid. So how could a world this cold possibly support life? The answer might lie below the surface. In 2015, NASA's New Horizons spacecraft flew past Pluto. What it found was astonishing. Vast ice mountains, flowing nitrogen glaciers, and, most intriguing, evidence of a possible subsurface ocean. Pluto has a rocky core surrounded by water ice. But heat from radioactive elements in the core may have melted part of this ice, forming an internal ocean. If true, Pluto could be like Europa or Enceladus, moons that may harbor microbial life in similar oceans beneath their frozen crusts. Life, as we know it, needs three things: liquid water, energy, and organic compounds. Pluto might check all three boxes. Water? Possibly. Heat from the core? Plausible. And organics? New Horizons detected tholins, complex organic molecules on its surface. If these tholins seep below, they could serve as food for hypothetical microbial life. Think of organisms like those around Earth's deep-sea vents, thriving without sunlight, using chemistry instead of photosynthesis. Could Pluto have alien extremophiles, hibernating in the darkness for millions of years? If Pluto has an ocean beneath its crust, the next big question is, could something live in it? It sounds outrageous at first. How can life survive in complete darkness, at sub-zero temperatures, with no sunlight, no atmosphere, and no certainty of liquid water? But here's the twist. Life on Earth already does. Deep beneath our oceans, sunlight never reaches the seafloor. Yet entire ecosystems thrive around hydrothermal vents, cracks in the Earth's crust that leak mineral-rich, superheated water. Here, strange organisms, like giant tube worms, heat-tolerant bacteria, and shrimp with no eyes, live off chemical energy. This process is called chemosynthesis, and it doesn't need light. If Pluto has any kind of internal energy, say, from its rocky core, it could have similar vents and similar life. But where would Pluto's energy come from? Despite its small size and distance from the Sun, Pluto's core contains radioactive elements, like uranium, thorium, and potassium, that decay over time and release heat. That heat could keep an ocean from freezing entirely, especially if the water contains ammonia, acting as a natural antifreeze. If the heat is strong enough to create pressure gradients or warm patches, hydrothermal activity could occur. And where there's chemistry plus energy plus liquid water, we might find life. If life exists on Pluto, it shatters what we thought about habitability. It means life could be everywhere, beneath the surfaces of cold moons, dwarf planets, even rogue planets without suns. This pushes us to rethink where we search for life in the universe. Instead of looking at distance from a star, maybe we should be digging deeper, literally. Of course, this is still a theory. No probe has yet drilled into Pluto's crust. But the idea of life in such a distant, frozen place is no longer science fiction. As new missions are planned for icy worlds, we might be just decades away from an answer. Until then, Pluto remains silent, but not forgotten. Enjoyed this journey to the edge of the solar system? Subscribe to Space Bounded for more cosmic theories, animations, and mysteries of the universe. Until next time, keep looking up.